Hello everyone, welcome back to more Turing Machine. I thought I'd run another hard game here with, I guess, 5 verifiers again. I didn't think too hard about whether I wanted 4, 5, or 6. You can ask for, the number of verifiers can vary independently of the difficulty of the puzzle. Which, I don't know exactly how that works, but I don't know how the puzzle generation as a whole works, so that's fair enough. As always, if you want to play on your own, the code is here, or you should just be able to copy it from the description. Type it into turingmachine.info. If you're playing at home with cardboard, it occurs to me I've been saying these are the numbers you want, but I think you probably still want to go to turingmachine.info and type in this code, or paste in this code, because this is enough, but like it doesn't tell you. There's like some complications for. Well, I can actually show you. Technically, like, it would be better if I never looked at this, but obviously it's, like, completely incomprehensible, right? The point is that every card has 4 different numbers on it. And it's not, like, choosing the orientation or something like that, which is what I guessed at first. This clearly specifies what the orientation should be. It's just they want to have 4 different ways to refer to each card so that people who are playing in cardboard don't learn accidentally, because they've seen it so many times, that, oh, 221, that's the one that checks that blue is 1, or whatever. So instead of giving it to you as 778 all the time, it gives it to you as like this one sometimes, and that one sometimes, and that one sometimes. So if you just look at these numbers, you would have to, like, you wouldn't know, like, TuringMachine.info says, look for purple 221, purple 482, and so on. And, you know, the only 482 is the purple one, but you don't know that just from these numbers. So I would suggest, if you want to play in cardboard, you should probably still not look at these numbers, but use the code in the description and in the chat here. Okay, and I think that's, that's pretty much it. If you don't know the rules, go look at an earlier video. If you want to play this before me and then compare our performances, now's the time to pause. And if you just want to like listen to the soothing sounds of puzzle solving, or you've already gone and solved it on your own, then let's get started. We're gonna have some fun. I haven't looked at these verifiers yet, so we're learning what to do. Okay, how many of these, out of curiosity, are hard ones? I don't think any of these are. This one, maybe not. This one is definitely hard. It compares one color to another. I think these could all be, like, the rest of these from here down are medium or easier. I'm not sure. It's somewhere in the 20s that it shifts from. Or no, maybe 18 is the last easy one, and then like 19 to 24 or something like that are medium. I don't know. Doesn't matter. So let's see. We have something telling us about blue. We have something telling us about evens. Something telling us about a total. And something comparing one color to another. Oh, God. Okay. And this one. So I don't see a ton of different deductions we can make. But I do see one that's easy. The even numbers, there can't be 3 of them. The reason for that is then D would be superfluous. So a sequence of ascending numbers. The first time I read this card, I didn't understand it correctly because I didn't look too carefully at the bottom right here. 1, 3, 5, I would say, yeah, this is in ascending order. But actually, what they mean is strictly increasing by 1 on this one. So ascending sequence means going up by exactly 1. So 2, 3 is 2 touching numbers where the second one is 1 higher than the second. So if If there were 3 even numbers, it would be impossible for any 2 of them to be ascending. And so we would know this, and this verifier would be telling us nothing. So we know there are, let's write that down, on B, 0 to 2 evens. And it's almost, let's see. We also know there can't be 3 numbers in ascending order. Because if there were, we would have this giving us no information. We would already know that blue is less than yellow, and blue is less than purple, and yellow is less than purple. And this could be a criterion verifying one of those 3, but it wouldn't tell us anything that this doesn't already tell us. So we know there aren't 3 numbers in ascending order. We can write down for D that there's only 0 to 2 ascending. What's the keybind for this? Is it F7? Yeah. 0 to 2 ascending. I guess we can also say something about E in how it compares blue and purple, right? If purple is bigger than blue, then there could be some numbers in ascending order. But if purple is equal than or less than blue, can't there not be numbers in ascending order? Nope, that's not true. Because we could have the sequence be like 2, 3, 2, and there would be a number in ascending order. Or it could be 2, 4, 2, and nothing in ascending order. So I don't think there is actually this comparison between this interaction between D and E where you require that blue be less than purple. Yeah. Okay, anything else? The sum of all numbers compared to 6. Most of the time, this is going to say greater than 6, right? Because the average value of a number is 3, and there are 3 of them. So, like, the average value of all numbers summed together is like 9. So 6 and less than 6 are pretty unlikely. But, and if you add any extra constraints, you can often get this to buckle. In particular here, if there were 2 even numbers, then we would almost have proven that it's greater than 6. We wouldn't quite have done it, but we'd be pretty close, right? Because the only way for there to be 2 even numbers and not be more than 6 when you add them all together is if there's 2 2s and 1 1. So if we can find some way to rule that out, for example, let's say we prove that blue is 3. Then we could rule out that there are 2 even numbers. Because they would have to be at least 2 each, and that would mean that just A and B would be enough to give us everything that C gives us, and C would be superfluous. So if we leave B alone for a while, or C alone for a while, no. If we leave if we leave B alone and ask A or something else, we might discover that some more about B without having to ask. 1 even number, I mean, we're probably going to have difficulty eliminating that. Oh. Wait, did I already do this? Oh. Yeah, if there's 0 even numbers, there also can't be any in ascending order, right? Because it has to be strictly increasing by 1. If they're all odd, none of them are different from each other by 1. So we can say there can't be 0 even numbers. There's 1 to 2 evens. Okay, that's nice. So in fact, if we find that blue is 3 or greater than 3, then we can ignore B. It'll tell us that there's exactly 1 even, right? Yes. Because there being 2, combined with knowing what A is, would make C superfluous. Okay, I stepped away for a second to address something else that came up in my real life. But where were we? We did all this stuff. Which is not a ton, but it's not nothing. And it tells me that I want to ideally query A, D, and E. D? Do I really want to query D? Ooh. I'm hopeful I can figure out what B and C are without touching them. But I might be able to figure out what D is without touching it too. It seems kind of hard. And finding out about D might help me with B, I guess? So let's try... Oh, gosh. I mean, we could try something completely wacky, like testing 3s all around. Right? That doesn't seem totally crazy. Or maybe 4s would be better. Because then A would be like telling me, oh yeah, it's greater than 3 2/5 of the time, which is fine. D, I would be confirming for sure that either there are some ascending or there are none ascending. Or wait. Yeah, I know there's 0 to 2 ascending. Right, there aren't 3. So this has 0 ascending, so it would solve D for me. And then on E, I would be eliminating the entire middle row. Is that useful? I'm not sure. I guess it's not great, right? Ideally, you'd like to eliminate like half with a single question, but I don't think that's possible, right? You can't ever eliminate more than 3. Because in each column, only one of the 3 relations can possibly be true. Oh, right. The point is, you're either going to eliminate 1 column or 2 columns, or 1 row or 2 rows. Or, well, 3 or 6, depending on... This query, 444, would either eliminate the middle row or confirm the middle row. So that's why it kind of looks inefficient. It's either going to get rid of 1/3 of the possibilities or 2/3, which averages out to 1/2, but isn't actually 1/2. So I don't know. It seems like any question you ask of E is going to have that issue. It's going to either eliminate 3 or 6. So I guess you could try to home in on the row and then on the column. Or you could just like test some random numbers and then try to form queries that, I don't know. I don't think testing 444 is a great opening plan, but it sure seems interesting. Let's test like 4, 5, 2. I don't know. This way D, I mean, it doesn't really matter. We're getting the same information from D no matter what sequence, no matter what numbers we use. So if we talk to D, it just doesn't matter what we ask. It's going to either tell us 2 ascending or none ascending. E and A are the ones we actually care a little bit about. Actually, I feel like there's a little bit more strategy in looking at A and E, isn't there? Because if we find out that A is greater than 3, or even if we find out that it's 3, then we'll know that E can't be saying blue is less than something, right? Because if it were, then C would be redundant. The sum of the numbers would definitely be greater than 6. So if we find out A is 3 or more, I mean, if we find out A is more than 3, then we can't even see that blue is equal to something. It would have to be saying that blue is less than something, or it would have to be comparing yellow and purple. No, not less. So blue is more than something. It couldn't say blue is less than something or blue is equal to something. Okay. So yeah, if we find out A is greater than 3, that would tell us quite a lot. And I guess I would maybe want a 1, 2 here instead of 1, 2, I don't know, smaller numbers, so that supposing I do hit on A, then E will still be testing, let's see. I'll know blue isn't less than any of these. So these two would both be eliminated. And I want my query to be covering around half of these 7 if I can. Obviously, you can only cover 3 of them. So blue greater than yellow, blue greater than purple, those are both covered. Yellow greater than purple, or yellow less than purple, also covered. So we would, yeah, if we hit on blue, we would still be covering 3 here. And I think that's the important thing, because that's sort of the best you can do. So I think I like 4, 1, 2. So let's go ahead and ask that. And start with A, why not? It says no. Alright, so unlucky. A is not greater than 2, sorry. Blue is not greater than 3, so we can eliminate these possibilities. Okay, fine. So let's talk to D, I guess. There is no ascending sequence. Got it? So we can... Oh, I wrote 0 to 2 ascending. I guess that's correct. No... How did I... Ugh. No ascending sequence. Okay. And I still think we definitely want to look at E here. It says no. So that's the most common answer and the least helpful one, but still good. Actually, I mean, not good. It's fine. I mean, right? It still eliminates 3 possibilities, which is the most we could have hoped. Which is the most likely outcome. We could have hoped for better, but this is what we expected. So this is like... Um, now, we know it's not checking that blue is greater than yellow, but blue could be greater than yellow, right? So I'm actually going to take notes in a different fashion here. Ideally, what I would like to do is draw on the card. But you can't do that for some reason I don't understand. Like, I can draw like this. I can't. The card is not a drawing surface. If I, like, lock... I don't know what causes that. But fine. So what I'm going to do is... This grid kind of mirrors the grid up here. And so we know that it isn't the case. So let's see. Less equal greater. So we know we aren't testing that blue is greater than yellow. And we're also not testing that blue is greater than purple, which is here. And we're not testing that yellow is less than purple. So we've eliminated these three possibilities from E. But any of the other six it could still be. And remember, I've said this like 15 times this video, but just because we eliminated yellow is less than purple, it doesn't mean we can conclude that in the actual code, yellow is greater than or equal to purple. Yellow might be less than purple. It just isn't what this verifier is checking. Let's like flip this one over just so I know I don't need to think about it anymore. I've already got it written down here. So we're definitely not ready to get the answer. Can we make any more deductions based on what we learned? Actually, I do need to think about this because of redundancy, I guess. Blech. So we want to talk to A to find out what category blue is in, I think, still. Because if we find out it's 3, that would still be fairly useful. It would give us a number, and it would eliminate a bunch of other stuff on E. But probably we'll find out it's less than 3, which makes it much harder. And we want to talk to E. So A and E and I guess B. Is my plan. So let's make blue be 3. And then I want to make sure I'm testing 3 different things on E. And I'd like to avoid testing the ones where blue is less than something. So that's top left and top middle, which, yeah, are both here. So I'd like maybe to have blue and yellow both be the same as, purple and yellow both be the same. Yeah, actually the middle row is pretty good, right? So maybe I do just test 3, 3, 3. I suggested it as kind of a joke earlier, but it was at the time a reasonable suggestion, and I think still is. Now, if I find out that A is 3, though, doesn't this mean this question won't tell me anything about E? I think it does. No. It would just tell me that I would be, if I find out A is 3, sorry, blue, if A tells me that blue is 3, then I'll know blue can't be less than anything, and it can't be equal to anything. According these criteria, that can't be the criteria. So I would actually be eliminating all 4 of these if I see that A is telling me that blue is 3. And then I could query D and find out which of these 2 it is, I guess. And if I find out that A isn't 3, then I guess this is still as useful a query as I can get on D. So yeah, I guess this looks fine. And what else am I querying? Well, I was hoping to query this to see if there's 1 or 2 even numbers. So maybe, I can't do that if I test all the numbers the same, can I? That is a problem. So what if I test like 3, 2, 2? Does that still have the useful properties I want? I've already ruled out, yeah, see, this is bad. 3, 4, 4? I've already ruled out blue greater than yellow or purple. This would let me query 3 less than, sorry, blue less than yellow or purple. These 2 here. And also yellow equal purple, which is this. And if I get lucky and find that blue is 3, then I eliminate all of this for free, and this still helps me test these. And I can still ask B how many evens there are. Yes, I think I like 3, 4, 4. So let's write that down. Oh, shoot, I didn't write down my third question here. Okay, but it must have been E. And E gave me an X. Okay, got it. Let's cross out all the F's. Okay, so 3, 4, 4, we're going to ask A about that. It says no. Well, that's not a huge surprise. So A tells us that blue can't be 3. It must be less than 3. So the good news is we can write that in. Blue less than 3. Celebratory circle. Ah, come on, get the cursor in the right place. And knowing blue is less than 3... Well, I mean, I think we might as well ask E, right? A check mark. Okay, that's sort of helpful. Sort of. So it's either testing that blue is less than something, or that yellow is equal to purple. So we can eliminate the ones where blue is equal to something, and the other one where yellow and purple are different. Oh, and we have to put a check mark here. I don't think this allows me to conclude anything about specific numbers that any of the colors could be, though. It is making it hard to figure out what C is, though. I wonder if I need to actually ask C now, just to make sure that in the next round I can narrow C down to a single possibility. Because all the ways I was hoping to prove that C has to be greater than 6 are sort of falling through, right? 1, 2, 2 is like very much a possibility. Or even like 1, 1, 2 or 113. No, we know there can't be no evens, so it can't be 113. I don't remember why we know that. Oh, because then there would be no numbers in ascending order, and that would be known. Okay. Ugh, I hate that I have to ask C this. But I think that's what I have to do. Yeah, what a shocker. They do add up to more than 6 together. Blech. So that's sort of what we thought would... Oh, I guess I didn't put a circle here, huh? Alright, whatever. The worst circle anyone's ever drawn. But I think if I hadn't asked C here, I would have risked needing extra rounds to keep querying C. If some of the other ideas didn't prove fruitful in time. So... if we ask E something now, actually, like, how are we ever going to get a unique solution? Is a question, I guess. It seems like yellow is going to have to equal purple, probably. Because if all we know is that blue is fucking less than something, and the other numbers are kind of big when you add them together, I guess, I don't know. If blue is less than something... yeah. Then whether we know there's 1 or 2 evens, it'll be way too easy to assign values to purple and yellow that meet all the other criteria, right? Let's say we found this out, that blue is less than yellow. Oh, okay, right. Here's how we can prove that yellow and purple are equal. This is easier. Right? If blue... I think it's not actually easier. It's just the same thing I said a minute ago in different words. If E is telling us, oh yeah, blue is less than yellow, or blue is less than purple, then, like, both yellow and purple could be 4 or 5, right? We could have them be 5-4 or 4-4 or 5-5 or 4-5 or whatever. All 4 of those would be possible without breaking any of these 3 rules that we know. No ascending sequence. Oh, that would rule out 4-5. Okay. But it could be like 3-5. No, it couldn't because there's 1 to 2 evens. So maybe there is some universe where knowing that blue is less than, let's say, yellow, could still lead to a unique solution. Because if I knew blue were less than yellow, and there was only 1 even number, could I solve this somehow? I think 253 would be valid. But so would 154? Right? So if there were only one even number and we had this, that wouldn't be solved. There could be no solution. What if there were two even numbers and we had this? I mean, 142 or 254? Those are both solved. So I think, yeah, we can't have that blue is just less than yellow. That doesn't lead to a unique solution. I think the same argument will hold for blue is less than purple. Because if blue is less than purple and there's one even, let's just make sure we do this. If there's only one even, could it be blue? Then we'd have blue, sorry, 2. The others would have to be odd. I mean, this could even be 1 and 5, for example. Or it could be 2, 5, and 4, or 3, rather. So there couldn't be one even in that. Could there be two evens? Or wait, right, yeah, one. Yeah, there's way too many ways it could work with one even. So with two evens, let's say blue is one of them. 2, 4, 3. 2, 5, 4. So those would all be valid. If 2 weren't one of them, we'd have 1, 4, 2. That's also valid. So yeah, this can't just be saying that blue is small and some other number is big, because there's no unique solution in that case. It has to be saying that purple and yellow are the same. Now, can we tell already whether there's one or two evens? I think we might have to ask about that. Because if there's, well, actually, if there are two evens, they have to be yellow and purple, right? Because those two are the same, and if they're both odd, there can't be two evens. So, and they couldn't be 2, because then the sum would be less than 6. We'd have 1, 2, 2. Also, that would be wrong because there would be an ascending sequence in that case. So if there are two evens, the code is 1, 4, 4. What if there's one even? Well, then we have a 2 here, and the others are odd. And they can't be 1s, because then the sum would be too small. And they can't be 3s, because there'd be an ascending sequence. But they could be 5s. So in fact, whatever answer I get from B, I will have a unique solution. But the solutions are different. So I do need to ask B how many evens there are. So I'll just ask about 3, 4, 4 again. Because it doesn't matter what I ask it about, I'll get the same information. And I'll ask B how many evens are there. There's only one even. Okay. And that should be enough to win, right? Because we have all the criteria nailed down. And we already talked about what would happen in this case. I just don't remember the answer. If there's one even, it must be 2. Well, that's true, but more importantly, it must be blue. Blue is 2. And then we need 2 odd numbers whose sum is at least 4, so therefore it's they're 3 or they're 5. But yellow can't be 3, so I think it has to be 2, 5, 5. That's just the only thing it can be. So let's first check at least that 2, 5, 5 is the only way you could meet all these criteria. Well, yeah, if I'm right, the E is telling us yellow and purple are the same, and there's only one even, and blue is less than 3, then blue has to be 2. The others have to be odd. They have to add to at least 5. So they would have to be 3s or 5s. But they can't be 3s because there's any sequence. So yes, this all sanity checks. The question is, did I make some error in any of these deductions earlier? I hope not. How did I prove all these things? I asked A. Well, okay, here, let's... C told me the sum is greater than 6. This one, like, definitely gets a check mark. We can see it in plain black and white here. E told me it was one of these, and then I did this kind of difficult, tedious case-by-case analysis to prove what seemed to me to be true, which is that it couldn't just be saying, oh yeah, that small number, it's smaller than one of the other numbers. That's just not giving you enough information to narrow down the code. But I at least confirmed that it's either checking that yellow and purple are the same or that blue is less than one of the two. That's what this check mark gave me. And then I eliminated the ones about blue being less than something using some logic that seems okay to me. So let's put a check mark there. I think that is the interesting one, but let's look at the others just to be sure. Blue less than 3? Yeah, we confirmed it's not greater than 3 or 3, so that's solid. 1 even. We confirmed that there aren't 2 evens. We confirmed there couldn't be 0. We proved without checking that there can't be 0 evens because then there'd be nothing ascending. And there can't be 3 evens because there'd be nothing ascending. So once we proved there can't be 2, there has to be 1. So I think that looks good. No ascending sequence, D. I already knew there couldn't be 3 in ascending order because then this wouldn't tell us anything. So then I asked it, are there 2 in ascending? And it said no. So there are none in ascending, yes. This all looks to me like it checks out. I think 255 is the answer. Let's go plug that into the website. 255 is what I wanted, right? Yes. This is the correct code. Oh, I'm so glad I didn't make another blunder like I did in all the videos I didn't upload. Okay, so let's just see if I beat the machine. We got no's from ADE in round 1. Round 2, we got no yes yes from ACE. And then in round 3, we got a no from B. The machine took 1 more question. So the same 3 rounds, but it asked 1 more question than I did. Okay, good. So I forget how long it took. Did I end up taking 3 rounds or 2 rounds in the last hard one? I don't remember. But this was cool, ish. I'm still mad I had to ask C. Because this is what I assumed would be true anyway. But I was just running out of other ways to prove it. And in fact, let's ask. Now that I know what all of these are... Wait a minute. Am I, like... What I'm about to say sounds stupid. Because I was about to say, oh, well, now that I know what all the rest of these are, is there some way I could have eventually proven that C is greater than 6? And the answer to that question has to be no, right? Because if that were the case, then C would be redundant. But I guess the point is not that using the others you can prove C is greater than 6, but that if by assuming C is less than 6, and assuming everything that's written on up to 3 of the other 4, that you could then prove something else is redundant. Yeah, okay. But it doesn't actually look like I could, right? Because, if I assumed that the sum were 6, and I knew that yellow and purple were the same, and there was only one even, Yeah, I think I could at least do a little bit of that, right? If I ignore the ascending seek constraint and assume that the sum is 6, don't I end up proving that that something else, that the ascending seek is still redundant? If there's one even, and yellow and purple are the same, then the even one has to be blue, which is less than 3, so it's 2. And if yellow and purple are the same but not even, how could they add up to 6? They couldn't, right? This no ascending seek would not help. Well, frankly, there would be no solution at all. So using these 4, or using, I guess, let's say these 3, A, B, and E, I can prove that the sum can't be exactly 6. Could I, using A, B, and E, prove that the sum can't be less than 6 somehow? If there's one even and it's blue, and yellow and purple are the same, no, well, sort of, right? Yeah, because if there's one even and yellow and purple are the same, the even one has to be blue, and blue is 2. So for the sum to be less than 6, yellow and purple would have to be the same. And not 2. And they would then have to be 1, 1. So by assuming all of these 3, or by knowing these 3 and assuming the sum is less than 6, I can prove that D is redundant. So it must be the case then that knowing A, B, and E, I could have proven exactly what D is without ever asking it. That doesn't mean that would have saved me steps, though. Because knowing what C is in round 2 helped me to narrow down what E is, I believe. Yeah, knowing that the sum was greater than 6 was part of how I was able to eliminate these 2 up here, I think, and settle on yellow and purple are equal. So I don't think I really made some huge blunder by asking C instead of putting it off. I think this was probably reasonable. Again, I'm sure an experienced player could figure this out a bit faster, but This still seems like a respectable score. You know, as always, if you guys played along on your own, I'd be interested to hear how you figured it out or what logical steps I missed in my own deductions. That's, I guess, all I have to say. Hope you guys enjoyed. Thanks for watching, and I'll see you next time.